Okay, dear all, it's time to start the second part of plenary session 1 to make sure we're not running too late into this afternoon and the evening. So we will start with the first speaker, who is Grigory Nikulin from SMHI, and he will talk on CORDEX, archiving, achievements, status, and perspectives.
Okay, thank you. Okay, so we're continuing plenary session and now moving more and more to scientific talks, but in this case my talk is a little bit somewhere in transition. So it's about a little bit more technical stuff and actually about CORDEX archiving. And usually we can just download data, but a lot of work is not so visible for people who are working with the developing of archiving specifications and so on, so on. So somehow it's very well hidden in background. So here I'm trying to give some kind of short overview about CORDEX archiving from the beginning, how we started about 5 years ago, and basically where are we now and what we are going to do for maybe next years. And here is a short history of CORDEX archiving, and basically all work began around 5 years ago in 2009, 2010. And basically all specifications, we just took a lot of experience from already finished projects, and it was Prudence and Ensembles in Europe and NARCAP in North America. And first idea in general, it was just about to have a very big central archive, central portal. So all the data sets should go to this portal, and then everyone can get them. But additionally, it was idea just to organize a number of regional data portals. But pretty soon already, we saw how everything is going with the CMIP5 activities, and of course, pretty soon advantages of a geographically distributed system like ASGF become apparent, and there was a decision that basically CORDEX should move in the same direction for distributing simulations as a CMIP5. And basically, CORDEX, our initial ideas about CORDEX archiving were adjusted towards CMIP5, and it took a lot of time, because basically we spent around maybe more than 2 years just trying to finalize CORDEX archiving specification, and it was a lot of people involved in this work. So the main focus in CORDEX archiving now is on ESGF, and basically first simulations were already available since September 2013, but still, of course, we have a number of regional data portals, so I will give a short overview about them as well. And here is just a short overview of CORDEX data team. Somehow all these activities were ongoing in Europe, and maybe one of the main reasons for this is just funding from the FP7 ICRC projects, and here it's a list of people who were very actively involved in developing CORDEX infrastructure, taking different aspects from configuration for ESGF, for writing CORDEX archiving specifications, how to construct file names, global attributes, and all this technical stuff. So, of course, many things to all of them, because it was a lot of work, a lot of time spent, and of course, it's many more people were involved. And this is just one example about CORDEX archive design document. So basically, this one, how it looked like in 2009 when we got this first idea. So it was only 6 pages. Very short one, including all variables. It was 2 pages with variables. And this is how it looks now in this present version, finalized in March 2014. And now it's 26 pages with a lot of details, some examples, and already we have no variable list. It's a separate document. And here it's a CORDEX variable list. So basically it's a reference what variables or groups running simulations supposed to save, to which frequency, and of course we providing all long standard names for netcdf files and so on and so on. And again, in 2009 it was very simple list, just 2 pages, basically giving just some kind of names. So now of course we can see that basically we're trying to follow the CMIP5 specifications and everything very well organized, following exactly the same names as used in CMIP5 by global models. And of course, we always should keep in mind that basically all information is available on the CORDEX website. So always you can go to the CORDEX website to experiment guidelines, and here you can find all CORDEX technical documentation for RCM groups and for empirical statistical downscaling. So about experiment protocols, how to submit your data for publications on ESGF or to regional data portals. And for the CORDEX users, you can always go to data access section and find how you can find and how you can download CORDEX data for different domains from different sources, and so on, so on. So usually we're trying to keep it updated with the latest information and so on. And at the moment, CORDEX simulations can be accessed in a number of ways. And as I already mentioned, so basically the main focus we have on Earth system grid federation. And as well, for 3 CORDEX domains, it's Mediterranean CORDEX, South and East Asia. There are regional data portals. Then we have a number of what we call sometimes impact portals, but basically, usually it's only for simulations available from the ESGF segment. And as well, sometimes we have servers at individual modeling groups, but it's not so very widely distributed. And basically, because it took a lot of time for developing CORDEX ESGF infrastructure and was really delayed because many groups already completed simulations and we were waiting, okay, when we can publish our simulations. And when we came with the CORDEX ESGF, so already we had 3 regional portals established and now they are working, I would say, very fine. For example, many of us know that ESGF was down for almost 7 months since June 2015. And during this downtime, basically all regional data portals, they were operationally because they don't depend on ESGF infrastructure. So one of them is Mediterranean CORDEX. And here it's, I would say, very well organized. And Mediterranean CORDEX simulations are available only at the portal. So basically no simulations available from ESGF. So all users should be approved, but it's a very quick procedure. You can get a very quick response saying that you are approved and you can go to download data. There is a terms of use, but basically it's saying non-commercial for all data sets. So somehow these terms of use sitting on the upper level for all simulations available from this portal. And basically there is very advanced search system with, you can search for metadata for different variables, scenarios, models. There is some web-based post-processing, so you can run some CDO commands just to calculate maybe seasonal means instead of transferring a lot of data. And of course, you can find a lot of different statistics. So for example, here one statistic for recently with 87 MetCORDEX users and a lot of data in numbers and in gigabytes. So another portal, it's East Asia. And here, registration is very simple. Basically, you're going to your registration and can download immediately. And then as well, we have, in terms of use, it's non-commercial for all simulations available from this portal. And additionally, some CORDEX simulations also available from ESGF. And in this case, most of them, I would say, they are unrestricted, so they can be used for everything. As well, there are some kind of services with plots for individual simulations and with multimodal ensemble mean. And as well, there is a service when people can just make plots themselves, just taking different combinations of different simulations. And last one, it's a regional data portal for South Asia. Basically, it's covering India, Bangladesh, and a lot of countries around. So here, users should be approved, and terms of use is not really provided, but there is a link to standard terms of use for CORDEX. But as well, additionally, some simulations from South Asia available on ESGF. So in this case, they are unrestricted. So this is 3 regional data portals. They are functioning, and yeah, you can find a lot of simulations from there. But as already, as I mentioned a couple of times, that basically the main focus we have now on ESGF because it's a very convenient way to distribute a lot of data in a federative way. And basically, ESGF is just very, very big international collaboration on how to work with the climate data. And this is a peer-to-peer infrastructure. So basically, it's geographically distributed data nodes. So there is no any central archive. So if one data node is down by some reason, it doesn't impact so much on all other data nodes. And basically, we had one big problem with some kind of security issue, and ESGF was down for almost 7 months, from mid-June of 2015 until February 2016. It was a very big problem for many groups because we got just really many requests to provide simulations here and here and here. Of course, it takes a lot of resources for providing this. But now the system is back to operation since February, and now I think all CORDEX data nodes already back again. So basically, you can download all simulations available on ESGF. And CORDEX EJF segment was in operation since mid-September 2013. So basically, it was a moment when first CORDEX simulations were published on EJF. So from this system, basically, CORDEX simulations can be accessed in the same way like you're accessing CMIP5 data or maybe observation from OPS for MIPS or reanalysis from ANA for MIPS. At the moment, latest statistic is here from May 10th. So we have around 2,200 users in the CORDEX EJF group. So you can see that basically it was always going up. So it was a downtime period. And quite often we have small jumps in users. So here it's just few numbers, a number of users per day. And quite often we can trace why we have, for example, 26 users coming in one day. Because basically, usually there is a summer school or there is a training workshop somewhere, and there is some introduction to EJF, and a lot of participants from this summer school going to EJF trying to get first CORDEX simulations, and in this case, you have such kind of small jumps. So at the moment, we have a number of CORDEX EJF data nodes. So almost all of them located in Europe, and we have a number of tier 1 nodes. So basically, these nodes providing also graphical search interface I will show in next slides. So status of May 2016, we have these 4 nodes for publishing data and providing search, but as well we have a number of so-called tier 2 nodes. So basically, they have data, but they have no graphical interface to search this data. But of course, you can use one of these to get data from any of others. And basically, it doesn't matter from which data node you're going to access CORDEX data, because basically you just generate a script or you're getting links leading to the same file. So you always can look how to access data at the CORDEX website. And as well, it was a lot of activities just trying to promote somehow EJF infrastructure for CORDEX in different domains, because usually it takes a lot of resources to run an EJF data node, and basically you need a really good expert to work with one EJF data node. So basically you need a technical expert working 100% just with administration of data nodes. So we already know that it can be a very heavy task. And 2 workshops were organized recently during the last 2 years. And basically, it was this focus on CORDEX Asia activity, and because a number of institutions are interested to install EJF data node for CORDEX publications. So one was in China in December 2014, and one was just 3 months ago in February in Korea. And both of these workshops, I would mention that it's very technical workshops. It's not explaining how to download data, but it's explaining to really how to install EJF data node, how to run quality control before publication, how to publish data on EJF. So it's very, very technical stuff. But I think it was very, very good success for these groups, and now we can expect so maybe at least 2 or 3 new EJF CORDEX data nodes in the CORDEX Asia domains. And here is, for example, how CORDEX EJF search interface look like here. So basically, you're starting as always from the CORDEX project. And here it's a number of data sets published. So one data set, usually it's one simulation, one variable, one frequency. And then you can select different experiments or different driving models or different regional models, time frequency variables, and so on. So at the moment, for example, if we're selecting the domain, so-called search facet, so we can already find 12 of the 14 CORDEX domains available on EJF. And of course, number of published data sets different for different domains. And here, actually, CORDEX Africa has the first place with a number of data sets, following by EuroCORDEX with a 50-kilometer resolution, and then by high resolution, 11 kilometers. And here, just for example, it's a list of RCMs available on EJF. So you already can see a long list of different regional climate models. Because as well, you can see that maybe some models can be popular, can be run by different groups, and so on. And we have all information about all CORDEX RCMs collected in a one central master list. And basically, if you go into CORDEX websites to data access, so you can find a CORDEX RCM list, and then you can have a HTML version. So you can find all acronyms for regional models, from where they came, who is a responsible institution for running simulations, and as well, you can find terms of use for these simulations. And in parallel, there is just a text list with exactly the same information, but it's machine readable. So it's very useful when you're using this for some kind of automatical post-processing for scripting and so on and so on. And basically, all RCM groups have to provide information about their models. So as well, because many of you are here, so it's just to remind you, so basically you should send these 6 points to the CORDEX registration email. So in this case, your model will appear in the CORDEX model list. And very common question, okay, so what's available on ESGF? And actually as well, we have one kind of service. So as well, if you go into data access and the CORDEX website, you can find a last point here, CORDEX data on ESGF. And in this case, you can get table like this, where you can see what is actually available on ESGF, sorted by different domains. For example, for Africa, and just small examples for EuroCordex, for South Asia, for Arctic. So basically, you can see how many regional models available right now and how many driving models for these regional models, so how combinations. And basically, this list is automatically generated every week or when a large number of data sets published. And I would say many thanks to DKRZ in Germany for providing such kind of this service. And here it's a little bit more statistics, most popular variables in CORDEX. So here statistics based only on SMHI RCI results, but it's around 130 simulations, including 7 CORDEX domains, so it's a very large database. And we can see relevant variables, which is about 50% of total CORDEX downloads. But of course, it's not a surprise that we have a precipitation as a most popular variable in CORDEX, following by mean and max minimum temperatures, and then following by radiation, evaporation, and finally 2 components of 10-meter winds. And another example of what we can get, basically, it's download statistics for CORDEX Africa. It's just a geolocation by IPs. So you can see basically which countries downloading data from Africa. So here you can see that basically Senegal is on the first place in CORDEX Africa, and then following by France, United States, and Germany, and then you have smaller amount from other countries. So basically such kind of statistics can be accessed for all CORDEX domains, so you have at least some kind of idea who is using your simulation. And one aspect, of course, for accessing data is so-called impact portals. And here it's one example for Climate for Impact portal developed in the ICRC project. And here, as well, you can get CORDEX simulations using this portal because it provides very user-friendly, simple interface for downloading CORDEX data, but in any case, you need a registration on ESGF to use this portal. But as well, it provides web-based post-processing, so you already can calculate a lot of statistics, averaging over domains, supposed to be some climate indices. And it's really, there is a promise to have this tool for statistical downscaling. And now we're going maybe just to a few slides about what we can expect in coming months or years, what new we can provide on ESGF from CORDEX. And one of it's bias-corrected simulations. So already we had a question from eHub this morning about how people can access bias-corrected simulations. And we get this, it's a very common question. It's very often coming, okay, I can download CORDEX simulations from ESGF, but where can I get bias-corrected CORDEX simulations? And basically answer is, it's not available at the moment. But in general, we have really many methods and many groups running bias correction, but usually it's not so easily available to a wider community, usually just within some projects and so on. And during the second CORDEX SAT meeting in February 2015, there was discussions and it was a decision to organize a CORDEX Adjust project on ESGF for distributing bias corrected, sometimes we use bias adjusted, it's interchangeably CORDEX simulations. So work is ongoing now. So basically we already have all archiving specification, how to construct file names, how to provide metadata with attributes and so on and so on. And basically we can expect pretty soon, technically we are going to be ready to make bias-corrected CORDEX simulations available. So here it's just a test configuration. It's not really data available at the moment, but you can see it's supposed to be CORDEX Adjust project. And then we're just following the same search elements as for CORDEX, but trying to include information about bias correction into one element bias adjustment. So basically, it's a combination of name for bias correction, observation, and period used for calibration. And as well, we make some modification for variable names, just appending adjust here, just to really distinguish between original variables and bias-corrected ones. Yeah, so basically, one of the problems that you can get CORDEX simulations bias-corrected by many different methods. So basically, what is going to be, it will be some kind of expansion of a number of simulations. So we always should keep in mind a number of points here. So bias correction is a controversial approach, I would say, and still debated, should we apply this or not? And it's very difficult to say which of bias correction methods is the best one. So maybe it's similar to selecting a best global original modeling. So simply there is no any clear answer. And as well, bias-related uncertainties for future climate projections, I would say it's really unclear. Yeah, because basically it's adding some kind of uncertainties in the chain we're running our post-processing from global models to regional models, bias corrections, and to impact models. So basically always think a little bit more and be careful with bias-corrected data when you're using them. And one of activities as well we're going maybe just to implement for CORDEX, it's climate indices. And there are many climate indices calculated by different communities with sometimes different definitions and so on. So of course, the main question here, if we can provide somehow these climate indices for CORDEX simulations in a coordinated way. And one of the main problems, so basically at the moment we have simply no somehow archiving specification for climate indices. I mean metadata for standard names and so on, And this work is ongoing right now, mainly within the CLIPSI project. So here is just one example of draft version for metadata for different indices when we're trying to define standard long names, units, and just to be consistent. So basically when such kind of specification completed, so all groups across all regions can use exactly the same definition. So at the moment we don't know how we're going to provide this, but one of possible solution can be just to organize something like CORDEX index project on ESGF. And as well, we should mention, of course, empirical statistical downscaling, because CORDEX is not only about RCM, but as well it's a ESD. But somehow now we are a little bit overloaded by RCM results, because ESD was a little bit delayed. And from ESGF and from regional portals, we can get only regional RCM simulations, but not ESD. And as well, one of the main problems is that ESD community is very diverse. There are many different methods, and usually empirical statistical downscaling is much more localized compared to size of large CORDEX domains. But in any case, now we have a work ongoing on developing and command metadata for ESD. So it's already, we have some first drafts, but still we have a lot of work to do. And of course, many technical aspects are really different between RCMs and ESD. And here, CORDEX is well supposed to be involved in CMIP6 activities. So we are, as a now diagnostic MIP, so we don't suggesting new experiments, but just requesting specific output. And here it's what we're requesting from CMIP6. So we may expect some changes into CORDEX archive design, just to be synchronized with CMIP6 tools. But in any case, I think the first CMIP6 data for scenario might be available somewhere in 2018. And my last slide is just about variables. So now we have a number of variables defined in CORDEX from the beginning 5 years ago. And then we found that basically, yeah, we missed a number of variables, and some approaches maybe not really useful. So for example, near surface relative humidity was not included into the CORDEX list, but it's a very popular variable. Basically, almost everyone requesting this variable. So now it's already fixed, but one problem is that many RCM groups haven't saved this variable. So another problem is we have only total soil moisture content, and basically it means it can be a layer of few meters. But of course, if you want to evaluate these results, satellite-based data usually showing only maybe upper 1 to 2 centimeters. So basically, maybe we should introduce something like a soil moisture in the top soil layer. One of most critical problems is that we have only 3 pressure levels. And actually, that's not enough for work in many regions, for monsoon circulation, for jet streams, for vertical cross sections. So basically, we think to extend this to more pressure levels to be synchronized the same as in CMIP6. But basically, its CORDEX domain should decide how many and which of these pressure levels should be saved, because one pressure level important in one region makes no sense in another region. And last point here is basically ocean variables, because from the beginning we defined only around 60 atmospheric variables, but not ocean. And for example, at the moment, CORDEX Portal provides a number of ocean variables, but it's only one example in CORDEX. So basically as well here, it's a lot of work just to prepare a list with ocean variables for all future CORDEX activities. Okay, so thank you for your attention, and any questions?
Okay, so there are room for a couple of questions, and do we have any? Oh, I see one arm up there, way up there, Rebecca. Meanwhile, while you're running up there, I could ask, this is a curious question. I still have a lot to learn about CORDEX being a newcomer. So just a curious question, on those statistics on what parameters are downloaded, did you also look at if there is a spread in what parameters are downloaded in different regions?
Basically, yes, we have statistics for each region. But I would say it's almost the same for all regions, at least for first 5, 6 variables, it's always precipitation and temperature. Yeah.
Okay.
Okay, Douglas Maraun, just a question, Grigory. Aren't you, in a way, doing the second step before the first step? Sorry, there's an echo here.
Yeah.
Is that... Okay, anyway. So, I mean, you want to upload bias-corrected results to the CORDEX webpage, and I mean, we are currently producing the results of value regarding bias correction methods, and there are lots of surprises. Okay, yeah, okay. So there are a lot of surprises. Many methods designed, for example, for extreme events, they completely fail for extreme events, and ontologically, I mean, you said it's a bit like having a multi-RCM or GCM ensemble, you're having a multi-bias correction ensemble. But ontologically, it's a completely different thing. Because with a bias correction method, you can really say whether it's wrong or right for a given purpose, whether the statistical method or model is designed in a proper way. So I would suggest to wait until we better understand the limitations of the bias correction methods before you publish anything which is more complicated than, I don't know, scaling or adding a bias or whatever.
Yeah, somehow I agree. So basically maybe it's one of questions for discussions here. Because from one side maybe we can be ready with the technical infrastructure for making bias-corrected simulations available, but as well, because we're running as well some evaluation of 7, 6 different methods, and yeah, we see many surprises sometimes. So of course, all such kind of details should be very well documented, but I think it's maybe very difficult to provide real guidance to the end users about bias correction, yeah, because it's so many different methods and so many different aspects. But as well, it's open question. So basically, we have next days for discussions about this, how to better to, yeah, if you're going to make them available, or if you're waiting some little bit more for documentation, or if you can select a number of methods. So
okay, there's one more question, and then we'll break for the next speaker.
Okay, I have a question on non-commercial use of data, because there's a growing demand from private companies from climate services, and they're willing to pay for those services. And on the other side, there's less and less funds available for fundamental research. So to provide climate services to private companies, a way to finance this less popular research. So I would like to hear your thoughts on that.
Well, basically your question about non-commercial terms of use, or what actually was the question?
How can we provide climate services to private companies if we're not allowed to? Did you hear the beginning of the question? Okay. How can we provide climate services to private companies if we are stuck with the non-commercial use of data?
Okay, but basically, from the CORDEX side, we strongly recommend to all modeling groups to make their simulations unrestricted. But of course, it's only a recommendation because we cannot force modeling groups, because quite often they can have some limitations, for example, by funding agency or by some other policies. So they cannot make their simulations unrestricted, and they put in these non-commercial terms of use. So in this case, basically, we can do not so much. But what we see now, so basically we have a tendency that many groups going to make their simulations unrestricted. And even groups who they before had a non-commercial terms of use, now relaxing these terms of use to unrestricted. So hopefully we can get maybe 90% of simulations with unrestricted terms of use, so climate services can use it for everything, but still we can keep in mind that maybe some number of simulations will be non-commercial only, and here we have nothing to do.
Okay, then we thank Grisha for this interesting, informative talk. And the next speaker is Linda Mearns from NCAR in Boulder, Colorado. She will give an overview of climate projections performed for North America CORDEX.
So a couple of things to know. Number one, I just got here yesterday, so I am jet-lagged. This usually tends to degrade my presentations. So we'll see how this goes. But there's always uncertainty, especially about climate. So I'm going to present an overview of where we are in progress in North America CORDEX. And I'm presenting, but of course this includes, like most of these projects, casts of thousands, many of whom are in this room. And the outline is pretty straightforward, just a description of the NA CORDEX program, some of the samples of results, era interim-driven runs, the GCM-driven historical runs, the climate projections, and what we're going to work on next. Now, I want to say that, and I know this is true of many of the programs, but in North America, particularly in the United States, if you don't have funding to do something, it's difficult to get it done. So I would say that NA CORDEX hasn't developed as quickly as we had hoped. But we now have a bunch of runs, and I can show you some results, and we have hopes that others will still join us. So the basics of the program, the domain covers most of North America, and it's, for the most part, larger than the North American Regional Climate Change Assessment Program, the NARCAP domain, which is a good thing for a number of reasons. The era interim-driven simulations, 9 different RCMs actually produced these runs, and one of them, the Canadian, the CRCM5, actually did it at 3 different resolutions, 50, 25, and 12. A number of them did 50 and 25. 6 of these 9 went forward to be driven by different GCMs for the 1950-2100 period, and some of these were done at both 25 and 50 kilometers, specifically those done by RegCM4, WRF, and RAN and CAN RCM4. And what I'm going to focus on are the results for the 8.5 scenario, but some of the modelers also did 4.5. Now, we are also establishing a regional hub, I guess it would call. We're going to be hosting some of the most commonly used variables from all the completed simulations at NCAR with access at nacordex.org. So here's the basic, some strange things did happen to this. Changing platforms, this was developed on a Mac. Anyway, what I'm showing here are the runs, the different RCMs that produced future climate scenarios, and you can see the 5 different GCMs that were developed, that were used to drive the RCMs. And I just want to point out that one of the nice things about these RCMs is that they span nicely the equilibrium climate sensitivity, going from 2.5 up to 4.6 with the HadGem2. And that's a nice feature of the runs that were generated. And this was not by design. As a matter of fact, none of this is by design. This is basically the runs that people largely wanted to do, although we did coordinate some of the RegCM4 and WRF runs. The indicators in orange are those runs that did both 8.5 and 4.5. And we do have several nice sets of runs, in particular the RegCM4 and WRF. All the runs aren't completed, but then we'll have two different resolutions, two different RCMs, and across three different GCMs. So that'll form a nice set. Then there's also several like the HIRHUM and RCA4, both using EC Earth, and so forth, as you can see up here. This is kind of a little ad for my colleague Melissa Bukowski. She's going to be giving a talk on Wednesday about the NA CORDEX runs for the North American monsoon area. So I hope you'll be able to go to that as well. So starting off with, we also didn't get as far as we had hoped. How many people really end up doing more than they had planned in a particular time unit? Keeping with that tradition, we have not accomplished as much as we had hoped by this meeting. You hand in an abstract months ago, and you think, certainly we'll have at least all of this done by then. And then you're amazed to discover, we don't. So what I'm going to be showing you is more of a sort of the typical model beauty contest, showing a bunch of results. And I've tried to tease out ones that are of particular interest. So we're going to start off with the ERA interim-driven runs. And first of all, our observed data set is from the AgMera, which is basically a reanalysis product from NASA, the GEOS-5 data set. And so here we have, just to orient you, if you're not familiar with the North American climate, here is the winter North American precipitation. And there are two interesting features that I'll be referring to. One is this area, of course, in the northwest, where you have that heavy precipitation from storms coming off of the Pacific. Another interesting feature is this bullet of precipitation in the lower Mississippi. And it's interesting to see what models can get one, but very few of them manage to get both. So we're going to start off with, yes, the RegCM4. And here is the precipitation. This is millimeters per day for the 50-kilometer scaled run. And what you see here is the model does pretty well. As typical of the RegCM series, there's too much precipitation, too much along the coast, and too much on the windward side of the Rockies. And it fails to get that bullet down here. And by the way, virtually all of the models from NARCAP failed to get that heavy precipitation bullet in the lower Mississippi River Valley. Speaking of NARCAP, here is the run from RegCM3 driven by the NCEP reanalysis 2, and it's very similar, actually. Here's an example of where the domain for NARCAP is much smaller than for NA CORDEX. But you see the same types of problems, too much precipitation, although this is more too much, and then too much on the windward side of the Rockies. So the RegCM4 is a bit of an improvement over the RegCM3 in that regard. Going to a higher resolution, here's just the Mera product from 0.22 degrees. And obviously, as always happens with higher resolution, you get a sharpening of some of the results, like over the Rockies. And the RegCM4, 0.22, it's very similar, of course, especially at this scale. I'm showing you a very large domain as an overview. But you'll see here that overproduction of precip, windward side of the Rockies, actually is exacerbated by the higher resolution. So you don't always, as we always know, you don't necessarily always get an improvement with higher resolution, and it still doesn't get that bullet. There's an incipient billet of precipitation, but not really well formed. Going to the summer, in North America, in the lower 48, we have this dry area through California going into Nevada, and then we have this gradient of precipitation going across the Great Plains, and then larger amounts of precipitation right along the Gulf of Mexico. So those are some of the major characteristics. XCM4, basically the dry area is extends a bit too far to the east. There's too much precipitation going down to the south. But basically, once again, all of these simulations, quite frankly, how shall I put this technically, there's not a dog in any of these simulations. Dog in this case in American means not a great quality. Good vocabulary word. And here again we have the RegCM3. Similar problems. The dry area goes too far to the east. There is heavier precipitation along the coast here, but it's a bit too much. Here is the 0.22 mirror. And I want to point out this area. I meant to circle this in red, but didn't get around to it. So at the higher resolution in particular, you can see this little precipitation decrease windward of the mountains, leeward of the mountains along the coast. And you actually get that with the 0.22 from the RegCM4. And that's a nice feature because, again, I'm giving you this very broad view of this whole continent, but obviously anybody who's interested in looking at results from Washington and Oregon would want to see that kind of detail. All right, then I've thrown in a result from the CRCM5. These were done by Katja Winger. And a big concern for the Great Lakes is, of course, the snow belts that result from the positions of the lakes. And you can see here, this is looking at the 0.11 resolution. They're much higher resolution with era interim. And you can see very distinctly compared to the 0.44, the improvement of these lake effect snows along here, although they don't tend to do that well over Lake Superior. And here's just the snow belt basically showing the areas. But again, if you're really looking at details, let's say in western New York, you'd want to be able to see those. So I want to say something about resolution limitations. And I'm not going to actually show a result here, but just point out how different the limitations can be depending on what area of the domain you're talking about. So these are results from Simon Wang et al. When he published the first analysis paper on the NARCAP simulations. And he looked specifically in the West, and I'm going to just show you the results from NARCAP from that Northwest there, and then also from the Colorado Rockies Area 4, and you'll see a striking contrast in how these models do. So I often say we'd be in a nicer world if all climate was kind of like that off of the northwest of the US. Nice, clear features that can be well represented in a climate model. So here we have that area on the northwest, and the models all do pretty well. Sure, there are some errors, but they get the seasonal cycle of the precipitation quite well done there. As opposed to the area over the Colorado Rockies where, well, they just don't do very well. And I think here is where, in order to get that minimally, you would need a higher resolution to really tease that out. And you may need more than that, but my colleague Roy Rasmussen and others at NCAR have gone down to, I think, 4 kilometers in this area, and of course get much better results. Okay, moving on to temperature. You know, pretty much the standard latitudinal temperature, and then, of course, colder temperatures along the Rockies. Here we have a result from WRF. This is the 50-kilometer NA CORDEX WRF run. And what you see here, it does pretty well, except it's a bit too cold. The coldness goes a bit too far south. You can see that right in Kansas compared to the observations. And then going back to NARCAP, also pretty standard distribution, except now this area is too warm. So we're going from sort of like too cold to too warm right here through the Central Plains. But again, both of them, you know, the basic pattern is in pretty good shape. Now moving on to a different model, the CAN RCM4 actually does quite well. I'd say it's one of the best on the distributions. And here it is with the higher resolution. And you can see they're extremely close. Obviously, you get slightly higher, or rather lower temperatures with the higher resolution, since the mountains are actually higher. Going into the summer, here are the observations with that strong warming going up through the plains, through here, and then, of course, cooler points along the Rockies. And here we are with the WRF Era interim run. I think it's fairly good, actually. It may be, no, it's not too warm. It may be a little bit too warm going up through the Central Plains, but not too bad. The WRF G is definitely getting up there a little bit too warm, but there's not that much of a difference in the two simulations from NARCAP and from the WRF 50. CAN RCM, here we have a situation where this model definitely gets way too warm. Remember, the scale here is in units of 5 degrees centigrade, so that can be quite a large error if you get into a different category. And then the 0.22 CAN RCM, you have the same problem of it being too warm. Okay, moving on to the driven by GCM historical period from 1970 to 1999. And here I'm going to focus on the CRCM5 driven by the MPI, Max Planck Institute, and the Canadian Earth System Model. So again, here's our Mera precipitation and the bullet there. And lo and behold, here is the version driven by the MPI. And finally now, and I want you to know, the CRCM5 wins the prize for developing that lower Mississippi bullet of precipitation. It's the only model that I've seen who successfully did this. So 3 cheers for CRCM5. June, July, August. The CRCM5, I guess it produces, no, actually, it does a pretty nice job throughout the basin, I think. And here again, you see that decrease up there in the northwest on the leeward side of the mountains, which is really nice to see in that kind of detail. The June, July, August temperature, Mera again, CRCM5, it gets a bit too warm through the center. The MPI, that's with the CAN ESM2. MPI is a bit better and actually gets the contours pretty much where they need to be. So moving on to the projections. Here we're going to just look at RCA4 versus Hirham, driven by the EC Earth. And by the way, you know, I've chosen these both because they create interesting contrasts, but also because some of the data were more readily available for graphing the results. So RCA4 here, and also let me say, having also directed NARCAP, it's very exciting to have new European models in the mix here, and new European global climate models, rather than the ones that are more based in North America. So, precipitation change. All right, this is the RCA4 driven by EC Earth, and here we're showing, changes in precipitation from the mid part of the century compared to the current period. And this, I'd say, is a fairly typical result. Here's the percentage change rather than just the millimeter change, which is kind of useful to look at because you see, for example, that the change through here as a percentage change is much more striking than the change just in the millimeters. And then, of course, also the drying through northern Mexico. Here, you see more drying. It moves further up. All of California, this is the winter. California is not in good shape here. And then here, if we look at the percentage change, we do see that drying going up through the Central Plains, but percentage-wise, it's not quite as grave. But northern Mexico and southern Texas suffer a lot here. So here we have the 4 minutes, 3 minutes, 5 minutes. 3? You were supposed to tell me at 5. You tried. Okay, well, sorry about that. All right, so we're going to kind of blitzkrieg through this. I just want to point out a few things. For example, here's the Hirham EC Earth results for summer. And some of these characteristics, like this strange, what I consider strange drying, and that looking back at the NARCAP results, I didn't see anything like that, but that's one of the advantages of having new models coming in. So I'm going to kind of race through these. Here's the RegCM4, HADGEM versus GFDL. Yes, and I wanted to get to this because we have this interesting situation in the Arctic Ocean regions where suddenly, never before seen, there are these major areas of precipitation decrease. I immediately sent an email to Ray Arrett, who did these runs, and asked him, what's the story here? I think his answer was basically no clue. So we haven't really had a chance to look into that, but basically let's say that is extremely suspicious. And here it is with the 0.22 result. However, with the GFDL model, it behaves much better, and at least it's increasing in the Arctic. Okay, and then here's the higher resolution. I'll just whip through there. Temperature change, just a quick comparison, RCA4, EC Earth. This is kind of interesting because we see this large warming through the Rockies, and I'm assuming just by inspection that this is likely due to snow albedo feedback. We have no confirmation of that. But then when we look at Hirham, we see nothing like that. As a matter of fact, a relatively smaller increase through the Rockies. So we're seeing very interesting contrasts, and we will be very interested in finding out what's going on in all of this, because it's, explaining what's going on, why we have these results on a process level, that is the real fun, and to determine if all the models have equal credibility. And I'm going to whip through these. So now what? First of all, hopefully, Melissa Bukowski at NCAR is going to finish the WRF runs, HADGEM and GFDL, so we'll have our complete set. We are archiving the data separately, so we'll be a separate node. Daily for most variables, and subdaily probably for precipitation. Bias correction, yes, so we'll be very interested to discuss that while we're here. We're also working with Uranos on the production of threshold event frequencies, and apparently we'll be discussing that here as well. Also, we've gotten some funding from the Department of Defense to form analyses of winter precip in that south central, what models, why they do manage to get that bullet correct or not, and then the Colorado River Basin. And then finally, there are some opportunities for using some of these results for the next U.S. National Climate Assessment, which would be a great thing. So that's it.
Okay, thank you, Linda. That was an interesting talk on the North American part. And do we have a couple of questions? We have time for, yeah, there is a question there. Sorry about that. I was
Thank you.
waving a little, but you didn't. Yeah, sorry.
Could I ask the question? Linda, you showed these differences with reanalysis and discussed mostly over land, but the biggest differences are over ocean. Could you comment on this? Will it affect your results over the land? Because the big blobs of anomalies is either over Atlantic or on another type of water bodies. Okay.
All right, thanks for that question. I agree it's important what's happening over the oceans, but no, I can't comment on that because we haven't really looked at it yet. These were produced, like last week, most of these, so we were kind of rushing to just get the analysis we got done, but yes, we certainly will look at that. Thanks.
There's another question just behind you, Rebecca.
Hi, Linda. I have a question about the GFDL, the global model, the Earth system, 2M. This design for that, you didn't think about the SIM3 or something like that? You prefer to use the Earth system, the 2M Earth system, for that matrix I saw there, forcing the RSMs?
Well, the thing is that we didn't choose anything.
Okay.
Okay? I mean, as you may recall, NARCAP had this nice experimental design, very deliberately fleshed out, but we had money to do the runs, and, we agreed together on how to do that. With in a CORDEX, people were just doing what they want. We had no funding, so people were just contributing and using whatever they wanted. So there was no design for the matrix.
Well, my question was because the ENSO signal, that's very strong on that particular model. Is there, the GFDL or system 2M?
I'm sorry, there's a strong reverb and I can't really hear you clearly.
Oh, I'm sorry. Oh, ENSO. Oh, the El Nino sign is quite strong for the GFDL or system 2M. Is it stronger for the historical? Yeah, they talk about this in their paper, the GFDL.
Oh, okay. I haven't read that.
Yes, it's a very strong historical, for the historical run.
Uh-huh.
And it's interesting also the CM3 because they have the new atmospheric model, the AM3. And the other guys, the Earth system, still keep the AM2 that's kind of similar to CM3. Mm-hmm. So that's just a comment.
Okay. Thank you.
Okay, thank you, Linda. And let's welcome the next speaker, which is Piet Termonia from Regional Meteorological Institution of Belgium. And he will talk on CORDEX.B, combining regional climate downscaling expertise in Belgium. Take that.
Okay, so does this work?
Thank you.
Okay, so let's move from a very big country to a very small country. So we are focusing here on this country. So it's not a synoptic scale, it's almost close to the mesoscale, but it's still a country. Let's first look at the title. And the title says, Combining Regional Climate Downscaling Expertise in Belgium. So it does not stand for Coordinated regional downscaling experiment. But if you combine the letters, surprisingly, it makes CORDEX. So, in fact, this is, as the previous speaker was saying, also in Belgium we need money to get people working. And in fact, I'm going to speak about some project that got funded by the Belgian science policy. And in fact, what I want to say is that CORDEX basically is the basis of this project. I think it was mentioned already this morning that CORDEX has been used to make people work together and to provide a sort of scientific basis for national activities. So I split my presentation in two parts. The first part is more about how the project is going, what it does, what it doesn't do. And the second part is a bit of an overview of where we are today in terms of deliverables. So the first thing about this project, what you have to know, it's basically a network. It's a Belgian network. And in fact, I put the people here. There are about 30 scientists working on this. And when we were writing this project, the idea was all these people are doing modeling. Let's try to figure a way how to make them work together. And these people are working in different institutes. So there are 8 of them. And in fact, there are 9 partners in this project. And all of them either cover atmospheric modeling or more what we would call local impact models. So now what is the scope of this project? I first tell you what is not the scope of this project. And in fact, I've written it here. CORDEX BE is not a project to provide enough resources for 9 partners for computing, ensembles, and climate runs. So it's not for science, and it's not for climate production. So then I explain what it is about. It's actually a frame to combine existing, ongoing, I stress ongoing efforts in the Belgian climate community to optimally bring CORDEX scale information to the Belgian local scales in a coherent way. So there are two keywords here. The first is ongoing efforts. Everything that you see was already planned. People had the resources to do this. And the second is the lacking thing that we figured in Belgium was a sort of coherence measures, because you see there are nine the teams involved. And in fact, what we mean by coherent is that if there is a stakeholder knocking a door of one of the 9, then since they are using different tools, they might give answers that look a bit different to the stakeholders. So we do science. We know that all the science is based on the same basis. So scientists know it's coherent, but for the stakeholders, that might be not so clear. So stakeholders should get the same information from any of the 9 partners. That's the goal where we want to be with this project. The project is running now. It's a 2-year project. It's quite short. It started last year in March, and we are now roughly midway. So it will run until March 2017. And there was €1 million foreseen by our Belgian science funding, which is quite little. But basically, this money is not to do science, but actually to make these people work together here. So I can now give you a bit of extra. There is a challenge behind this, and this looks quite similar to what we had heard in the discussion this morning. You can sort of identify a twofold challenge in this. Each partner in Belgium has strong links, already existing strong links with Belgian stakeholders. And this includes tailor-made modeling activities. And that means that they have models that run at very high resolution and that can give parameters that are not in the databases that were explained very nicely in the first talk of this afternoon. So all these partners have tailor-made activities. On the other hand, a single partner is not capable to capture the complete spread and the uncertainties that are present in CORDEX. So that's a dilemma, and this is the challenge. And we want to combine this with what I wrote here, namely to come to a way where we can provide coherent information to the stakeholders. So the solution to this answer is, of course, it's CORDEX. So if my acronym is related to CORDEX, it's really related to CORDEX. And CORDEX is the basis. And the idea is that we sort of coordinate the working of all the partners to situate each of their contributions within the spread of the CORDEX ensemble. Secondly, we combined all the expertise to get coherent Belgian climate information. And there is a research part involved in this project. Namely, we would include an activity on statistical downscaling to infer uncertainties that come from CORDEX onto the Belgian scale. Okay. My colleague Bert van Schaibroek made a very nice diagram. So this is a sort of landscape of the activities that we are covering here. I mean, we have something like 4 objectives in this project, but it's very nicely summarized in here. And in fact, this diagram starts with, let's say, the impact models. That's the goal. So if you look at it top down, it's what we need and it's basically what is the goal and what is needed. And if you start from the bottom, you start basically what the scientists are doing, namely starting from the global scale to the very local scales. So, of course, we need the global models, but the CORDEX B project starts here. So the first goal is to actively contribute to the CORDEX project. And there are 3 models involved. There is an Alaro 0 model, there is a version of the Cosmo model, CLIM model, and there is a model called MAR. This is used to run it according to the prescriptions and the guidelines of the CORDEX project. And all these communities also run models at high resolution, something between 4 and 5 kilometers. And in fact, there are other partners in this project who do more other modeling, which we call local impact models. There is a group doing modeling on waves and storm surges. There are some groups working on urban modeling. There is a group working on crop models. And the last group is working on biogenic emissions. And then the idea is that we use the spread that that we can find in the archive to translate the uncertainties that we find in all these simulations here in the upper box. Okay. So what does the project pray for, actually? In fact, it's basically the coordination is not about the science. We don't say what science the people should do, but we coordinate which models should be run, which are the couplings between the different levels. Here you have the different levels, CORDEX runs, CORDEX B runs, local impact models, and which scenarios people would plan and sort of plan it in a time frame that we would end up with sort of overall picture that would be representative for Belgium. And in fact, the outputs here are agreements on variables and file formats, which actually go beyond what is being submitted in the CORDEX archive, because we need specific outputs here to run these local impact models. So basically, the project is about the green arrows here, and there is an extra part here on statistical downscaling to infer the uncertainties, which is related to this oval green. These green ovals here, which comes in a later part of this project, where we would apply some statistical downscaling to estimate the uncertainties on the, let's say, local impact models. 3 minutes? Okay, I'm halfway. I prepared some outputs already. I will go rather quickly on this. As I said, the project is midway. So here are the models. We have this kind of scheme. I can go fast over this because this sounds very familiar with you. The 3 models, CORDEX runs, high resolution runs, and this is the procedures. We have some outputs already. This is CORDEX runs with the Alaro 0 model. There will be some presentations later during this, there will be some posters later during this project of Rosemien de Troch, Bergmans, and Van Schaibroek explaining a bit more about these models. We run the models at 4-kilometer resolution and 5-kilometer resolution. We are specifically focused on added value. There is a nice poster of Rosemien de Troch who will present some results on added value in the Alaro model. Here is something specific. There is a partner included that is a specialist on GNSS activities, and they will prepare in the next year some data set that will be used to validate these models based on integrated water vapor contents. Okay, we also plan to couple to this coherence and this one model to have, this is also for the second phase, the next year. This is an activity to couple these models to the 3 operaire models to have some simulations of storm surges and wave heights. And we also have we also have surface modeling to model urban effects. And there will be a talk of Rafik Hamdi later in this workshop about this. I would like to spend 2 slides now, which I think is important. And that is, I think, from our perspective, there are 2 groups included in here, which already are a bit the next level users for us, so to speak. This is our expertise, or domain of expertise in upper air atmospheric modeling. It involves dynamics, but this involves a bit more of chemistry and biology. So here is an example of one of the institutes who is running a biogenic emission model to simulate the emission of isoprene. And this is, they told me, I'm not a specialist on this, but this is important as a sort of in chemical cycles that produce ozone in the atmospheric ozone. And this study found that according to the ALARO 0 climate scenarios that we have computed so far, we may expect an increase of ozone peaks in summer in the, according to these two, the 8.4 scenarios. This is another example. It's about simulating mice production, and this is it's fresh. It's not published yet, but so it used also this ALARO simulations. And in fact, this group found that we can expect an increase of production and growing days per year if you look at the end of the century according to the different RCPs that you see here. Now, this is illustrative of this project because this was done with variables that come from CORDEX, well, that we produced, but that would go to CORDEX. But during this research, they found they need some fine-tuning, and they would, instead of having just daily precipitation, have more detailed precipitation fluxes, and also use potential evaporation fluxes, and not just evaporation that is there. And so this illustrates the point about this project, that now we have a collaboration between our modeling group and this modeling group, and then we can go a bit further to have a bit more of tailor-made provision of data. So here I think I still finished. Okay, we also have a part that is that will focus on climate estimation of climate uncertainties. We would like, this is already a product of this project, where the group of Nicole van Lipzig at KU Leuven actually did a simulation of heat stress. These are maps of heat stress, and we like to organize them according to a low, median, and a high. And these scenarios have been already established by Patrick Willems of KU Leuven also. And that's where we want to go to. So we will somehow want to define this low, median, and high based on the CORDEX spread that we will find there. So this is planned. It's the first result here, but more will come next year. Okay, I will stop here. So what as a few concluding remarks, the CORDEX runs are either finished or ongoing. We're almost finished for the ALARO 0 model. They're not submitted yet to the archive, but we're almost there. I showed the first use of data in local impact models with these different models here. More are planned. For instance, this wave model will be done next year. We will plan to have a research project for the next year on the inference of the uncertainties. It will start now, soon, the coming month. I forgot to say, we store more data than the ones requested by the CORDEX guidelines. Basically, from this ALARO model, we can recompute everything. I mean, any variable like CAPE, profiles, we can recompute it. We plan validation against GNSS data for the next year, and we also had discussions with some of the authorities, and they requested a study on invasive species and another one to create vulnerability maps. So this is what I wanted to say for this time.
Okay, time for maybe 2 short questions. Try to keep them short. I don't know if I see any. It's hard to see up there if there's anyone waving. No, I don't see it. Yeah, there's one. Yeah. Rebecca.
With this coordination thing, with respect, or in comparison to the CORDEX?
Could you repeat the questions?
Yes, okay. What is the benefit with respect to the overall CORDEX program? It is actually, this is a sort of scheme that we have to follow to get to the stakeholders, and it becomes more and more eccentric. We started with the models themselves, and then slowly we get to internal stakeholder, external ones, and then we end up here to society and policy. And in fact, this project becomes from request from policy. So they ask the question to the Belgian community for really specific, I mean, speak about the national adaptation plan, things like this. And that's actually the origin of this. So we're forced to put our community together, but since we can only do this if you use CORDEXs. So it goes a bit further than CORDEX in that sense. It's more specific questions. It's more local in some sense. But CORDEX is the basis for this.
Okay, thank you. So I have no more questions. We break for coffee.